Thank you.
And I'll see you later, Trevor and Chris.
Okay. Yes. Hello. Right. It's like a chair meeting. Hey, everyone. Right. So now we are rolling into the session about the low-level APIs that sort of underpin the immersive web and that integrate with WebXR. WebXR is itself kind of a low-level API compared to things like the document object model or CSS, but it doesn't live alone in the browser. There are several other low-level APIs that sort of go hand in hand with it. And so that's what we're going to discuss today. And today we have 3 people who are all currently from Google, but I know that I think all of us on the panel have worked at other browser teams as well. So we have somewhat of a diverse perspective on that front. We have Quarantine, Chris, and Brandon, all from Google. And why don't we do a quick round robin and just say hello and say what you do at Google, and then we'll roll into the discussion.
Sure. So I'm Chris Wilson. I obviously work for Google. I co-chair the Immersive Web Working Group and Community Group, and I actually do a lot of kind of high-level standards work at Google for the web, and that's kind of the definition of my job more than anything, I guess.
Brandon?
So Brandon Jones. I work at Google on various browser graphics and immersive APIs. Previously worked on WebGL. Am currently a editor for the WebXR specs, and am currently working on the WebGPU implementation in Chrome.
Yeah, and hi, I'm Corentin, or Quarantine as you wish. So I'm also at Google. I'm co-chair of the GPU for the web community and working groups, but it's just like the web GPU group essentially. And at Google, I also kind of lead the implementation of web GPU in Chrome and like with various libraries and stuff. Try to get that out ASAP. And yeah, previously I was working on WebGL and Angle, so kind of similar space.
Yeah, I think that's actually a great lead-in to what I think is the first question is, so WebGL exists today in various versions and various different browsers, and then there's this sort of common underlying implementation that some of the browsers use called Angle. Maybe, Quantan, if you can talk about how Web GPU fits in with sort of the evolution from WebGL in terms of graphics that relate to XR.
Okay, so there's like multiple aspects to the question. So the first one is in terms of implementation. There's a similar model to what we have in WebGL, where there's Angle that implements the API in native, and that's used by the browser the various browsers to implement it for JavaScript. So for WebGPU, we have for Chromium we have a library called Dawn, and for Firefox there's a library called WGPU in Rust, and it's the similar thing where they implement in native and the browser exposes that to the web. And what's cool is you can use them in native. So that like. What's nice with WebGPU is we're going to have more implementations than just Angle, so more diversity is good. In terms of API, there's a couple of big differences. The big one is that WebGPU is more modern for sure, but it's also designed for the web. So where WebGL is a straight uplifting of OpenGL to the web, WebGPU is more JavaScript-y in a sense, and it looks more like it fits in the web platform, even though it's kind of weird. So these are kind of the main differences, apart from the additional features, of course.
And so, thank you. That's, I think, a great summary of the sort of the place that Web GPU fits and the graphics aspect of how it fits into XR. But I think one of the things that a lot of people don't understand is how things like Web GPU and WebXR and Web Audio, and to some extent WebRTC, how those all fit together as low-level APIs to allow web developers to sort of sync them together to build higher-level experiences. I know, Brandon, you've done a fair amount of work of building higher level experiences that exercise a lot of those APIs. Maybe could you talk a little bit about the relationship of them, and when developers approach it, maybe how they could think about the interrelationship of those?
Yeah, sure. I mean, all of the APIs that we're talking about here, it feels a bit weird if anybody's used to systems programming or programming directly against native GL or D3D or the audio codecs or anything like that. But they are kind of low level as far as the web is concerned, in that it's not you don't go to these APIs and say merely, all right, just throw up a couple of triangles over here and then play this sound and then we're good. They are designed to give you a lot of control over what's happening, and that control is often very verbose. And so, really we expect that a lot of times people will be utilizing them through higher level libraries, such as 3JS or A-Frame. I gotta rep the shirt from
Nice.
DAO. Yeah, there's a philosophy behind these APIs, though, that what we want to produce is not so much like the easy to use thing that satisfies the 80th percentile of what people want to use, because you can do that. You can target and say, well, we think that most everybody wants to do, say, 360 video with WebXR, and some of the stats that we have actually prove that to be true. There's a lot of people who just want to watch 360 video on a cardboard headset, and we could build APIs that target specifically that set of use cases. But that's not going to be what works best for everybody, and so we build these lower level APIs with the idea that they will be very composable and very flexible to satisfy what most people need. And we do have to make some concessions for the fact that we are on the web. We're in a very privacy centric environment. We're in a sandboxed environment. There are some hurdles that we have to get over with that. But we're really trying to build something that people can come and piece together those building blocks in the way that suits their needs specifically, and ideally build higher level, more targeted API, more targeted libraries on top of them to serve the average people's needs, such as a 360 video player or a chat app or something like that.
Great, thank you. And Chris, I know you work on a lot of different standards, and you work pretty heavily in the incubation of new ideas for the web itself. How do you think about the relationship between higher level APIs like the DOM APIs or CSS versus what Brandon was talking about with these lower level but highly composable sort of fine control APIs like WebXR and WebGPU? From a web perspective, a web standards perspective, how do those things fit together, and how do you decide as a in the community on which way to go with these things?
So a number of years ago, there was this manifesto that was signed, the Extensible Web Manifesto. And the Extensible Web basically said, do proper architectural layering in the web. And there's a lot of subtleties to this, but it basically is like, think down what kind of bedrock APIs you're trying to expose to people and give them access to. And then don't build just the top level infrastructure, like the top level, easiest HTML tag level thing to ship, because they're going to want access to those lower levels of capability too. And that's why we've gone through and built things like WebGL and WebGPU, where you get very low level access. It's really fundamentally what the WebXR API itself is. It's not defining virtual worlds, it's getting access to the hardware and being able to build it into a system that provides these virtual worlds. And that means for things like web audio is a great example, where it actually does have some higher level semantics built into it, but it gives you low-level access to the audio hardware also. And because it's defined at a relatively low level, it's not just play back this sound file like we used to have with the audio tag. It can provide things that let you set up and combine with some of the other APIs. And then you get frameworks or implementations that build and use all of these together, like 3JS, for example. It builds on top of WebGL. It builds on top of WebXR if you're doing a VR scenario. And it uses web audio, which has a built-in 3D positioning panner, and uses all these to provide a very convincing 3D positioning of sound in a VR scenario. And as a user, this is actually quite easy to build, like quite easy to set up and attach a sound to a particular position in space. Now, there are some subtleties that come in and some challenges that come in when really low-level things can be very, very powerful. And we have to be very careful about how they get exposed. We don't want to provide tons of fingerprinting surface area accidentally, or we don't want to, enable security problems by giving direct access to some bits. So there are some places where we provide higher level semantics as well. But I think the challenge is really looking through the use cases and scenarios. And this is something for incubation purposes we've gotten better and better at in the web. Probably over the last decade or so, really thinking through, well, what user use cases are we really trying to provide here? What do developers want to do, and how can we expose it in the right set of ways?
Great. Yeah, that balance, working in the WebXR community, I know that balance is definitely tricky. And one of the aspects that I thought was really interesting that I think all three of you would be able to speak to is how, as we move to these lower level APIs and we make them more and more capable for reasons of performance or flexibility and modularity, how do we avoid violating one of the core tenets of what browsers promise users, which is that they won't be uniquely identifiable? We call it fingerprinting a lot of the times, but I know that one of the things I hear from a lot of developers is they want to know what GPU, they want to know the name of the GPU it is that they're addressing, and they want to know, sort of all these really specific details about the hardware so that they can more accurately target their experiences to them. How do you think about addressing, balancing that need to be able to have performant and device-specific capabilities versus letting users trust that when they go to a website, they won't, as much as possible, will prevent them from being uniquely identified as individuals?
I guess I can maybe start on and then I think I'll then Chris can follow up probably. But so it's true for like flexibility or just being able to choose the most optimized code path in various places. You want to know what you're running on. Something that we're discussing at the moment in the WebGPU group is, for example, your machine might be capable of WebGL2, but not capable of WebGPU. And in this case, we might provide you with a software implementation of WebGPU just so you can test things. But you as a developer want to know if you're running on software, if you can also run on WebGL, because then the best experience will be on WebGL instead of WebGPU for that particular machine. And so to do that, the question is, how do you expose this information in the APIs so the developer can make the best choice? And that's one bit of fingerprinting, for example, for is my WebGPU adapter software or not? And so there's a lot of discussion around this, and the kind of the difficulty we're in right now, like as the web API folks in general, is that we browsers are collectively figuring out what the privacy story of the web should be, and there's multiple approaches being discussed. And so that's where Chris can talk more about. But I think because we're in this kind of middle ground state where we don't really know what the exact story for the web is going to be, I think it's important that API is designed so that the browser is in control of what it exposes. So for example, we may have a name for the GPU you're using in WebGPU, but there will be provisions in the spec to say that browsers are allowed to fake the name, and if they fake it, then they probably should use this name so that it all seems like the same. Just this type of thing so that the browser is in control and can choose depending on the context. If you're in an iframe, I can add iframe, for example, maybe you don't get as much power, things like that. But put this flexibly in the spec at the moment so that as the privacy story for the web crystallizes, the browsers can make the right choices. But I'm sure Chris has more to say about that.
I don't know, that covered it pretty well, I think.
Okay.
So I'll speak a little bit to like WebXR API specifically in this realm, because this is something that is, the hardware that we're talking about has the potential to be very, very personally identifiable. And this is coming from things like, if I've got a headset on, like there's going to be a whole bunch of micro movements of my head that are moving around that like I can generate or hand information. Like we do have hand tracking in some of the modules. And this is fingerprinting in a very literal sense. I'm getting like a structure. Yeah, I know. I'm getting the structure of your hands and everything like that. And that's going to be fairly unique to you. And there's a natural tension between saying, well, we can't just smooth over some of this data. Like if you're taking your head motion and trying to smooth away the identifiable information, you're probably going to make people sick because you're no longer accurately representing their head motion. So how do we deal with that natural tension? And in a lot of cases, it's about structuring the APIs in such a way that you're giving the user a chance to make informed consent about using it. Mm-hmm. So what we're very concerned about with WebXR, for example, is making sure that we expose the absolute minimal amount of information until you as the user say, yes, I want to engage in an immersive experience here. I'm clicking on the button, we pop up something that says, this is what the page is about to do. Do you give consent for this origin to do that? And once you say yes, then we can unlock a whole bunch of information because you've indicated that you trust whatever whatever page you're interacting with to handle that responsibly. Now, this isn't a perfect system. Sometimes there will be pages that you feel like you should be able to trust and they're trying to do something nefarious. But what it does prevent is you're not going to go to some random web page and they're going to be able to do what we call drive-by fingerprinting, where they can just say, well, I'm going to poke at all these APIs while you're reading an article and generate this perfect profile of you from your XR hardware that you just happen to be wearing while you're looking at, say, the in-browser view of the page or something like that. That's absolutely not what we want. We want you to make sure that you are aware at all times when your browser is using that hardware, just like browsers are very good about surfacing when your camera is being used or when your microphone is being used, because that is a similar level of sensitivity of the data.
Yeah, that's a really good point. I mean, we had a lot of similar issues even with web audio, where it's very easy to accidentally expose functionality to the point where this is why we have autoplay limitations, where we won't automatically allow people to play audio. It's not just a user distraction. It's also, you can play ultrasonic beacons and somebody else might be able to pick them up or do things like that. And we have to fundamentally, if you have access to microphone, you have to understand that that's a very powerful thing, and that you may not even hear things that people can pick up, right? You can hear ultrasonic beacons. They're actually a really useful thing in some cases. And because of the way audio works, just like what you were mentioning with small head motions and things like that, you can't actually smooth them out without really damaging some of the core scenarios. And this is a fundamental concept of, we have to inform users and make it so that information isn't too noisy, right? That users actually get it and understand what they're enabling access to.
Do you see a lot of room for different browsers to choose different levels of access or user interactions for these sorts of privacy, or sort of not just fingerprinting, but also like you were saying, access to audio. Is this something where we can look forward to having different browsers have different approaches to these entirely? Is that one of the things that you're working for?
I don't know if different approaches entirely is the right way to think of it. I do think absolutely different browsers will set the dials at different places for their users. They will have different approaches to things. I don't think anyone would ever, turn on all of the things just like without any user consent or anything like that. And I don't think anyone, like, turning everything off also results in a pretty basic experience. But somewhere in the middle there, you're going to have very different scenarios. And one of the things that I've found really interesting in past history was even once we started using the web platform to do things like kiosk systems. You understand it's a totally different scenario. Like, user consent doesn't mean the same thing because your user walks away every minute or so, and a new user walks up, and how do they know that they just turned on audio recording or something like that? Like, these things have to be presented to users across a different set of scenarios, and it's not like we need a whole new underlying platform underneath them. We just need different ways of thinking about those permissions and different ways to expose them.
Yeah. Another example in the same vein, kind of the opposite of the kiosk scenario, is PWA. When you've installed an app to, like, your desktop or home screen or whatever it may be for your platform, that in a way can be treated as a certain level of consent because you're making the choice to say, I want to have this more readily available. I want it to be treated more like a native application. I probably don't want to be spammed with consent dialogues every time I open that up. And in the case of something like WebXR, we may be able to say, well, if you've installed this to your home screen, maybe we can just jump you straight into the immersive experience rather than having you click through to that button, which is so critical to the drive-by web. But when you've installed it in this particular scenario, it becomes more of a usability thing to just be able to jump straight in there. So there's a lot of things that get considered.
Hi, guys. Thanks so much for joining us. Hi. We've got some great, yeah, thank you. Thanks, Trevor. We've got some great questions coming in, and we've got a fan of Brandon's here. But the question obviously goes for all of you guys. I've got, they're coming in. I've got, I think, 9 questions now that we've got great interaction happening from our viewers. So how do you see the future of highly interactive parametric 3D models? Are there plans for things like GLTF, GLB to support instancing and tiling? And would you build these in an editor like Blender using custom codes like JavaScript or in an alternative format? Who would like to take this one on? Brandon, it's meant for you.
On the question, so I guess I better go first.
Go for it.
I'm a big fan of whoever asked this question. So, so in terms of things like models like GLTF and GLB, one of the things that we get asked a lot is, like, why can't I just have a model tag? And, like, there would be certain benefits to that, but in many cases, anytime we discuss it, it actually ends up feeling more like it's more beneficial to allow these composable low-level APIs that we've been talking about to pick up the slack and actually handle some of the heavy lifting for that. So a really good example of how this works out in kind of an ideal scenario is that we have the model viewer tag that was built by a team at Google, and you can go and link to that resource from your page and just put a single tag in pointing at a GLTF file, and then it does this nice little embedded viewer. And the cool thing about that is that can keep evolving at a very rapid pace because it's a single user space library, not a standard. Standards move slow, in case y'all didn't know. We try our best, but they are slow moving, and they tend to play catch up with some of the more proprietary APIs. But if you have a user space library, then it can catch up really quickly with all of the new bells and whistles that come out of something like GLTF, which is a constantly evolving format. It does get things like instancing and tiling as extensions. It's gotten compressed textures. It's gotten new material formats. It's got all these different things that go into it, and so a lot of times those type of uses we do see best as building on top of these low-level facilities that we've built. And in terms of building them, like it's really like building those assets. It's really up to whatever you as a user are comfortable using, especially with standardized formats like GLTF. They're getting to the point where you can export them from just about anything.
Amazing. All right. The next one is, will WebGPU disrupt WebGL-based engines, or is there a slower incremental migration possible? I don't think anything's slow these days, but who's got an answer for that one?
I could take this one. So
Sure.
Thank you for the question. So in a sense, it depends what you mean by disrupt. WebGPU is a completely different API compared to WebGL. So there is some amount of rewriting that is necessary to port an engine to WebGPU. We tried to add things like compute shaders to WebGL, but it was extremely difficult, so we abandoned that effort in favor of WebGPU. But in an engine, there's a lot of things that are not specific to one graphics API. A lot of the algorithms, a lot of the model loading, a lot of the scene graph, all of that is not dependent on the graphics API. And so we already see frameworks like, so Babylon.js is almost completely ported to WebGPU, and it's some effort, but it's not rewriting the whole thing. And 3.js is also porting at the moment, and it looks like it's not an insane effort either. So there's no incremental migration possible, but it's not like rewriting your whole engine either. It's just the graphics part.
Great. Okay, let's get through some of the questions keep coming in. So let's try and answer them. From Google's perspective, what are the plans for desktop WebXR and Chromium in comparison to mobile, between cool Android WebAR features and Oculus's phenomenal work in the browser? Feels like desktop WebXR is a bit on the back burner in comparison. Who would like to take that one?
I'll take this one really quick. So first off, full marks to Oculus for their truly phenomenal work on their browser. It's a great environment to work in. And we do see that a lot of just general WebXR use comes from Oculus platforms. Similarly, like AR tends to be the thing that most people interact with on mobile devices outside of like the 360 videos scenario that I explained earlier. And desktop, it tends to be a smaller slice of that pie. And as a result, it gets a little bit less attention proportionally, because there's just not as many people using using XR devices in that environment. We are still working on it. And in fact, I want to give a huge shout out to the team at Microsoft, because they've been doing a bunch of excellent work in Chromium in conjunction with the teams at Google to move the OpenXR backend for our WebXR API forward. And they're doing that in order to target the Windows Mixed Reality platform as well as HoloLens. So there is continuing efforts happening in that space. They're probably just not as visible because that tends to be one of the lower usage scenarios.
All right, I think we might have covered some of these. Is there anything that we didn't cover? Our non-Chromium browsers, I think we just talked about, did we just talk about that?
Yes, they are.
Yeah, and WebGPU. Let's see what else. What resources would you recommend to learn more? That's a good one, because I always think, what would you like to share with somebody else? And we're coming up to the top of the hour. So, maybe each of you could share some of your tools that you would advise other people to pick up and learn. What would be in your toolkit to suggest others to do the same?
So for WebGPU, we don't have a lot of content yet because the API was still in flux, so people don't necessarily want to take the time to update things all the time. But we have some kind of a landing page at webgpu.io where there's the implementation status of various browsers, and at the bottom there's a bunch of links to samples and demos and some articles. And I think we'll just take a look at that page and update it, because webgpu.io is a super easy to remember URL, so we should just update that page. We'll take a look after this.
Yeah, on the WebXR side, I would say like there's the WebXR samples page that you can look for to get an idea of how the low-level API works. But honestly, if you're just getting started in this space and you just want to throw cool things up on screen, I'd suggest looking at things like 3JS, Babylon, A-Frame, PlayCanvas, some of these better-known libraries, because they have a wealth of tutorials that go along with them, and they have these APIs implemented kind of at their core, so they can do really good things with them.
Awesome. I think one of the last ones, well, it says, will Chrome and Google get same origin WebXR navigation like the Quest? Do you think?
That is probably not going to happen, at least with desktop Chrome right now, because one of the big advantages that Quest has is that they have an in-VR browser, and we just don't at the moment. And that makes it much easier to surface this kind of information about kind of seamlessly going between origins. So that's just one of the advantages that they have that we're not able to match right now, and it tends to make it harder to do features like this.
Okay, all right. Well, I think we're at the top of the hour, and on behalf of all of us at the WebXR Developer Summit team, thank you so much for joining all of us in this panel today. Right, Trevor?
Thank you.
Thank you. It was
so
great.
much.
Thank you.
Yeah.
The low level
Thank you so much.
part of the story is an extremely important part of this story. So I appreciate you all three coming in and helping tell it.
Awesome.
Yeah, so I think we have a break coming up. So until 15 after the hour.
Yeah.
And so that'll.
And we have a great afternoon. Like, hopefully nobody goes anywhere. We put this break in there to get a coffee refresh, a bio break, and when we come back, we've got Metaverse. My company is actually presenting our CTO, so you'll be able to take a look at that. The W3C committee. Chris, you're back on stage in a little bit. Yes, you're back. And we have Trevor is also doing another presentation with us. And then we have React XR. We've got some more on performance and optimization and universal AR. So we have a packed day ahead of us. This is only the beginning. So make sure you take that break, but come back right away and we'll be ready to start off in the next 15 minutes. So wherever you are in the world, we'd love to find out where everybody is in the world. So maybe we'll throw up a Slido screen. The team can, in the background, throw something up and we'll find out where everybody's located. It'd be interesting to see because we have watch parties going on everywhere. And it's really great to see so many people tuned in to learn about WebXR.